day, viewers and listeners. My name is Ismail Inus. I will take you through introduction to software engineering, and we are going to look at the overview. We are going to look at the history of software engineering, how software engineering started. Also going to look at the evolution of software engineering. Welcome back again. This is just a recap of what we've looked at last week, which is issues of professional responsibilities. Look at intellectual property right and computer misuse, among the others. So let's continue from this week now. Okay, we are going to look at abstraction today. We'll define abstraction before we start. We said abstraction is the process of simplifying complex system by focusing on the essential features while ignoring the irrelevant details. In the software, when you look at a requirement, we have functional requirement and non-functional requirement. So in this aspect, we are going to look at the essential, that is the functional requirement aspect of the system, while we ignore the irrelevant or non-functional requirement of the system. In software engineering, focus on essential aspect instead of dealing with very minute details, that is the non-functional requirement. Developers focuses on core functionality and behavior of a system or component, while the hidden complexity is the abstraction hidden in internal implementation detail of a component, that is presenting only the necessary information to the other part of the system. We have an example here where we say a class and object. Okay, we look at in object-oriented programming. Classes represent an abstract concept, while objects are instances of those classes. Also, we look at an application in data structures. Data structures like stack and queues provide an abstraction interface for managing data, hiding the underlying implementation details. We also look at an application program interface. That is, application program interfaces provide a simplified way to interact with complex software system, that is by providing the graphical user interface. We now also have decomposition. We say decomposition is the process of breaking down a large complex problem into smaller, more manageable sub-problems, just like we have in object-oriented programming. In software engineering, divide and conquer is a method of decomposition. That is, divide and conquer is by breaking down a large system into smaller modules. Developer can focus on individual components without being overwhelmed by complexity of the entire system. As we earlier said, a team of developers can be constructed to develop system in a modular way. Then after the system, the modules will now be all integrated in one place. We also have improved maintainability. Smaller modules are easier to understand, modify, and debug. Also, if there, then we have the modularity. Decomposition promotes modularity, where different parts of the system can be developed and tested independently. We also look at the techniques where we have functional decomposition, that is breaking down a system based on its functions or responsibilities. That is, you can break down the system and relate it to its component that are related to. Then we have object-oriented decomposition, breaking down a system into objects that interact with each others. Okay, now we look at the relationship between abstraction and decomposition. We have the complementary aspect whereby abstraction and decomposition often work together. They work hand in hand because both of them divide the program into manageable parts whereby it can be handled by the programmers. Then we have abstraction guide decomposition. By identifying the essential aspect of a system, you can determine how to decompose it into meaningful modules. Decomposition enables abstraction. By breaking down a system into smaller parts, you can focus on abstracting the behavior of an individual component. look at the benefit or advantages of abstraction and decomposition in the field of engineering, software engineering. It reduces complexity of a system by making sure that complex systems are easier to understand, design, and implement. Also, it improves maintainability, easier to modify and update the softwares. It increases reusability, which allows for the reuse of software components in different contexts. And also, it enhances collaboration. This facilitates teamwork by allowing different developers to work on different parts of the system concurrently. As this is working on the maybe transaction aspect of a website, the other one is working at the front end of the site, the other one is working at the back end of the site, whereby at the end of the day, all of them will come together and integrate the modules together. So when you look at, in summary, we can say abstraction and decomposition are fundamental principles in software engineering, and they help developers to manage complex softwares. They improve code quality, that is the source code, they improve their quality, and also they create more robust and maintainable software systems.